Hello, hello, testing. Alright, my mic is working. Nice. Hello, good morning, or afternoon, or evening, wherever you are. Hi, Ganta, Rohit Chowdhury. Hello, welcome to the stream. We're trying more Facebook/meta questions that messed me up in previous weeks again. Alright, I have a list of questions that's been messing me up. Whenever a question messes me up, I write it down, and if it really, really messes me up, I put a star next to it. We're doing another starred question now. Leetcode 670. Alright, let's get started. Leetcode 670. Leetcode 670. Maximum swap. Okay, you are given an integer num. You can swap 2 digits at most once to get the maximum valued number. Alright. I think I remember this one. 2 will swap with 7. 7 is like the biggest one. 9 will swap with... Wait, it's already the biggest one, so... Seven will swap with... Wait, this is already the biggest one. Okay, so if you can't swap your biggest one... Alright. There's also the case where it's like... I don't know, 2, 7, 7, 6, something like this. If you have two options, like to swap with the biggest number, then you take the furthest one. Because, you know, 7, 7, 2, 6 is greater than 7, 2, 7, 6. Yeah. If you have the opportunity to switch to the biggest number and there's multiple of them, choose the last one because we want to shoot the smaller number as far away as possible, away from the most significant digit. So what we have to do is, I feel like we need a cache from 0 to 9, right, to track where the furthest from the left location is for each digit. Each digit's, last position. And then for each digit, we go from left to right. And then we were like, okay, from 9 to myself, what's the first number that I can swap with? If I find a number, then I swap it. So we'd be like, for number 2, we'll be like, okay, from 9 to 2, what numbers can I swap with from the right? Oh yeah, you have to make sure the indices are to the right too. And you can be like, okay, 7 is to my right. Well, first 9 doesn't exist, 8 doesn't exist. 7 is at 1. Okay, that's bigger than me and to the right of me, so we can swap it. Yeah. And then you break after that and you return the number. Okay. I feel like that's the algorithm. And then 9973. You look this. Is there any number 9 for me that I can swap with? No. Same for this one. Is there any number 9 through me that I can swap with? Excuse me. No. Okay. I think I have an idea how to do this then. But first, How do we convert an integer to a character array? Java to character array. Alright, this will be way more convenient. What about to integer array? Int to int array. Okay, well, this is good enough. There'll still be the same comparisons, right? Num array is equal to dot to character array. Okay, very nice. For every single, yeah, we need to track which the furthest index from the left of each number. So for character digit in num a, we will need a hash map for the cache. Int, or maybe just an array, since we only have 0 through 9, yeah. Cache is equal to int new int array with 10, so 0 through 9, okay. Should this be character? Sure, character. Wait, int. Oh wait, do these map to indices well? I don't think so, right? Characters? How do you convert a character to a, oh, integer.parse int? Okay. Is that really the way to go? Should I do a hash map instead? Hash map character to integer. Sure. Is equal to cache is equal to new hash map. Okay, for every character digit in num a, we update its last position, yeah. So cache dot put digit. Oh, we need the index somehow. For int I is equal to 0 while I is less than num a I plus plus. Char current char is equal to num array dot get character at I. Okay, and then cache dot put digit I. Yeah. Okay. Let's do a sanity check here. Let's return -1 by default. And then we'll print out what our cache is. System.out.println cache. Cannot find symbol I. Oh, it's num. Well, I is less than num a. Oh, dot length. Num a dot get. Oh, this is a string function. cannot find symbol digit. Current character I. So many compilation errors. Nice, okay. So we have 2 is at 0, 3 is at 0, 1, 2, 6 is at 3, 7 is at 1. Okay, very nice. 9 is at 0, 1, yes. 3 is at 0, 1, 2, 3. 7 is at 0, 1, 2. Okay. Very nice. Okay. Okay, now we need to iterate through every character, and if we have a chance to swap it with the biggest number to the right, then we do it. Yeah, okay. If we have a chance to swap with a bigger number to the right, then we do it. Yeah, okay, let's do that. For int I is equal to 0. You know what, I'll just copy this for loop. Okay, that's my current number. Let's call this num or digit for clarity. Digit is equal to this, and then you go for int swap option is equal to 9. Okay, we have to be careful here. So not only do we start iterating from while the swap option is greater than or equal to 0, swap option minus minus. Yeah, so we go from 0 through 9. Greater than or equal to the digit. Maybe just greater than the digit, 9 through the digit. Yeah, so for 2, we start from 9 to 3 if we can swap anything related to that. So if I see a thing, if hash dot contains key, swap option, and it's to the right of me, and hash.get swap option, the index is greater than I, which is my current index of the digit, then you can swap. Yeah. Yeah, do the swapping. Character temp is equal to num a I, which is the original digit. Commander Thrashing says, what's the problem? It is maximum swap. You're given an integer num, swap 2 digits to get the maximum valued number. Yeah. Let me make this smaller so it's easier to see. Yeah, welcome to the stream, Commander. Hello. You know what? I might just do a helper function here. Swap num a, that's the character array. And then we have I. And then we have swap option. Okay. What happens after this? We have to break outside the for loop, right? We don't need to swap anything else. Okay, this is tricky because we've broken out of this for loop, right? But we also need to break out of this for loop. Maybe we'll also have a variable called boolean and keep iterating is equal to true by default. The outer loop will keep iterating if keep iterating is equal to true, but over here in the inner for loop, if we need to stop iterating, then we set it keep iterating to false. Keep iterating is equal to false. Yeah. And in the end here, we need to convert our character array back into back into a integer. You know what? Let's not do that yet. Let's just do a sanity check to make sure that the character array is correct. So we'll do arrays.toString num_a. Yeah, num_a. I'm missing a swap function, right? Private void swap, which takes in a character array. Let's call this num array, int I, and int j, the things that you're swapping. System dot, okay. Let's do character temp I. Let's start what was originally an I. Which is num_a I. We will replace I, you know, index I with the value of j from a j. And then we'll replace what was originally at j with, well, we'll just replace the value at j with what was originally at I, so temp I. Okay, that should be it. I is equal to j, j is equal to what was originally an I. Okay, nice. Okay, let's print out what we printed out. Two 2736, 2736. That does not seem right. 9973. Okay, we're doing good on this one because you don't have to do anything. 2736. Are we not swapping anything? The cache is right? 27 is 1. Okay. Okay. 9 swap option is greater than the digit. Swap option minus minus if cache.contains key swap option and cache.get swap option is greater than I. Let's print out what our swap options are. System.println swap option plus swap option, and also the current digit that we're looking at. Digit. You might be comparing int to character. Oh, hi Kevin. I might be comparing int to character. So the comparison would be here. If cache.contains key swap option, the value of the cache is integer. And I is an integer. I don't think I'm doing that, am I? And system.out.println in your for loop condition, if swap option, oh, I see. Okay, that might be it, yeah. Yeah, that might be it. Java character to, wait, I can just do integer.parse digit. Yeah. Integer dot parse int digit. Commander thresh. Commander says, let me try to solve it in a nice way. Mind giving a link? Sure.
From that article.
Alright, there you go. Alright, there you go. Am I not allowed to chat here? Okay. Let me log on to my non-incognito window. Chat. Spinny eyes. Alright, there you go. Plus swap option. Okay. Yeah, this is getting pretty complicated. Oh no. Character cannot be converted to string. This is really complicated. Okay. Dang, okay. So we're getting 2, swap option 9, 8, 7. We're not even considering to swap 7. Okay, that's not good. If cache.contains key swap option. Oh. Oh, I think I know what's going on. The cache will never contain a key. Because it stores characters, not integers. Okay, okay. Yeah, okay, okay. I guess integer.parse int current character. Is that how we do it? Digit. We can make this simpler too by putting the integer.parse stuff here. Integer.parse int Okay, let's try running this swap option. Cannot be converted to a character. Let's do integer. Oh no. Line 4. Wait, why is it still a character array? Oh look, it's swapping 7 now, it's swapping 7. That's good. Okay, it's trying to swap 7 now. That's pretty good. Okay, but... I see, I see. It's swapping 7, not the actual... not the index. So swap cache.get, the swap option. Run this thing. Yeah, okay. We got the right answer now. 7236, 7236. 9973. Okay, very good. So now all we have to do is convert this back into a character. No, integer. Yeah. I feel like this is way too complicated. Okay. Let's compile everything back into a string. Character array to string. Wait. New string. Oh, nice. String result is equal to new string. Num array. Return integer dot parse int the resulting string. Run. Accepted. Nice. Okay. Oh, hey Dragon. Dragon says same in JavaScript. You sent me a link. Dang. That's really short. String num. Okay, n is string.length. Swap the pairs. Dang, is it really that short? Mine is gonna be longer. Wait, does this actually work? IJ. Reform the num and update the max. Oh, wait. This is like brute force. Are you like, you like swapping every single possibility? All right, I see. Okay, let's try submitting this. I'm gonna keep the print statements at first. We're probably gonna get time limit exceed. Wow, it worked. I didn't even remove this print statements. Okay, let's just remove everything. Delete that, delete that. Bro, let's go. Thank you. It still beats 5%. Am I still missing any print statements? Oh, here. Okay, submit. Alright, now we beat 31%. Still not the best, but it's fine. How could I have made this like shorter? I'm still not sure about converting everything to a character array. It seems so like so roundabout, you know? Could I have converted just to an int array? Digit is equal to... Commander says that way I didn't realize a thing. I less than num a.length. Keep iterating. It's actually non-trivial to like adjust a digit in place. Adjust the digit in place. Like swap itself with itself. Oh, yeah. Commander says, frick, do I actually have to convert it to an array now? Hey, you're having the same issue as me. Commander says, yeah, well, I was hoping that. Never mind. Alright. Cool. I think for convenience, I should have converted this to an int array instead. Maybe I just keep mod 10 and keep dividing it by 10. It would have been more convenient. Dragon says 1 millisecond is crazy. How Java that fast? Honestly, I don't know either. I want to try... you know what? Next problem. Next time I probably would convert this to an int array. Yeah, just keep mod 10 and dividing by 10. You don't have to do the dumb, you know, integers that parse int stuff. Yeah. Should we try an exercise like that? Nah, next time. I'll do it next time. Okay, what's the next start problem? Let's do... well, we ran out of start problems. The next problem is 227. 227. It's not start though. Leetcode 227. Basic calculator. Oh, this sounds really difficult. 227. Given a string s. Wait, how is this not a start question? Given a string s, which represents an expression, evaluate this expression and return its value. Oh no. The integer division should truncate towards 0. Should truncate towards 0. What does that mean? Dragon says, I hate calculator, all about stacks. You may assume that the given expression is always valid. All intermediate results will be in the range of this. You are not allowed to use any built-in function which evaluates strings as math expressions such as eval. Oh no. Okay. How did I not start this? So, we have to follow PEMDAS too. 2 times 4 is 4, plus 3 is 7. Nice. 3 divided by 2 is 1. Is that what they mean by truncate towards 0? Okay. 3 plus 5 divided by 2 is not 4 because 5 divided by 2 is 2 plus 3. Oh my goodness. What a hassle. Okay, the first thing I'm seeing is we should probably reduce or remove all the white spaces here. I'm thinking we can do one pass for the multiplication and division. Yeah. And then another pass for addition and subtraction. Java, how to remove white spaces. The strip method. Okay, this is just for trailing. You know what, can I just skip white space when I get to it? Sure, okay, I just skip white space when I get to it. Oh man, what a hassle. Should I do, maybe I'll put everything to a string builder. String builder, SB is equal to new. String builder for appending. Okay, and then for int I equals 0, we're doing just the multiplication and division. Handle mult and division. I is less than or equal to s dot length I plus plus. Okay, can we assume that, okay, s is guaranteed to be a valid expression, so if we see a multiplication sign, we're guaranteed to have another digit after it or number next to it, so we don't have to watch out for that, I guess. Okay, character, the current digit or the current character is equal to s dot character at I. So if C is equal to a white space, then you just continue with the for loop. Okay. Yeah, okay. What happens if we see Fishy says hi? Hello, hi Fishy. Welcome to the stream. What happens if we see a number, right? If character dot is digit, is that how it works? The current character. Is that how we check a character as a digit? Java character is digit. Dixon Chaudhry says, hello, bro. Hello. Hi, Dixon. Welcome to the stream. How you doing? If character is digit, okay. Can we check? Okay, we should probably check what the next operation is, so. Dixon says, love you from India. Thank you. I appreciate. There's pretty much guaranteed to be an operation after this, right? Right? I feel like there is. Let's just assume there is for now. Character operation is equal to s.character at... Oh wait, what if there's white spaces too? Oh no. Yeah, we have to watch out for white spaces too. How do we... Lowell says, Java string builder remove last character. Delete character at... The character index we want to delete. Okay, I have to somehow store the character, so when I get to a operand, operator, I know what my previous character was. How do I do that? I have a really dumb idea. What if we just do one pass and get rid of all the white space first, so we're guaranteed to have no white spaces? Oh, that's so stupid. I think it'll work though. sp dot Dikshant? Oh. Bro, my name is Dikshant. You pronounced my name a little bit wrong. Okay. Sorry, Dikshant. Oh. Dikshant, I see. sp dot and current character. Okay. This is so dumb. Okay. Get rid of white spaces in this pass. You know what? We'll do a sanity check. System.out.println sp.toString. I am missing parentheses. s.length. Missing parentheses again. Equals. Wait, what? Oh. Let's return -1. Just so we have a return type. Wow. Index 5 out of bounds. Oh, less than s.length. Okay. We're finally putting out something. Are the white spaces removed? Yeah, they're being removed. Okay. Nice. Okay. One more pass. Let's process division and multiplication. Just basically copy this. maybe now s is equal to sp.toString. sp is now equal to a new string builder. Okay, so we're guaranteed to have no white spaces now. Useful C++ may be useful in this type of question. I've never really used C++ for Leetcoding though. I've only known Java. It's all that I know. Okay, so what if I come across a digit for the first time? If C, if character dot is digit C, next digit, character operator is equal to s dot get character at I+1. Okay, and if the operator is equal to multiplication, which is this, or operator is equal to, I remember the double equal signs, division, then the character second operand, operand 2, is equal to s dot character at I+2, I guess. And then we must, do the division. Dikshan says, bro, I am first year student and I am so confused. I don't know why I'm unable to build my logic. Please guide me. Well, I'm not sure, to be honest. Depends on what logic you're trying to build. Okay, I'm not going to do any division so far. I'm just going to do a sanity check, like system.print ln. Let's do C plus the operator plus the operand 2, just so we know that what we're multiplying and dividing. Yeah, and then after this we should add increment I by 2 plus equals 2 to get to the second operand, and then we'll continue. Yeah, sb.append C. We'll probably skip out the operator and the operand number 2 when we print out sb again. That's fine though. Yeah, let's just see what happens now. Wait. Just to make it clear, this is SB. Let's run this thing. Okay, nice. Yeah, it's identifying that needs to multiply 2 by 2 now. Very nice. Yeah, okay, it recognizes that needs to divide 3 by 2 now. And then, yeah, it recognizes 5 divided by 2. Very nice. Okay, we're on the right track here. Lol says, at Dictiont, you can try doing the Java DSA course once and solve the LeetCode problems step by step. If you're in the first year, it will take around 8 months to learn Java. Oh. Sounds like sound advice to me. Okay, so instead of just printing out what we want to multiply or divide here, we can do if operator is equal to multiply, let's do C is equal to the original C. Oh, we need to convert it to an integer though. Dang. Java character to integer. Oh, here. -0. Okay. Minus the character 0. Equals C minus the character 0. Oh. Times the operator 2. Operator 2. No, wait. Operand 2 minus the character 0 to convert it to an integer. And else, if it's division, we do the opposite. C is equal to divide. Okay. Okay, let's see how many compilation errors we have. But if everything works, we should, from int to character. Oh, I see. Dang. Do we really have to convert it back? Result is equal to -1 by default. Result is equal to that. Okay. How do we convert an integer to a character? Java integer to character. Oh, you just cast it. Really? Okay. Alright, apparently we just cast it, which is nice. So C is equal to character result. Is that it? Okay. Run this thing. That clearly doesn't work. They lied to me. This doesn't work. Character for digit. Oh, character.toChars. Integer backed into character. C is equal to character dot to character result. Is that a thing? Integer digit to character. Oh, plus. Okay. You know what? I'll probably go with this one. Result. Okay, what is this? So, oh, wait. Let's print this out before we mess up the value of C and run this. Okay, cool. Yeah, we're doing it right now. 3 plus 2 times 2. We recognize that we must times 2 by 2 first, so now it becomes 3 plus 4. Very nice, okay. 3 divided by 2 is equal to 1. Okay, we already got the solution here, nice. 5 divided by 2 is equal to 3 plus 2. Okay, nice. So now we need to handle the addition portion now. Process, addition, subtraction. I'm going to copy most of this here. Okay. C is the current character. If the character is a digit, it's pretty much guaranteed to be a plus minus, right? So we don't need this portion, I believe. Yeah. We can delete this portion. And you know what, to be safe, I think we should still keep it in. It doesn't hurt. Operand 2 is this thing. Result is -1 by default. If the operator is plus, then we plus it. Else, if it's subtraction, we minus it. Okay, result is that. I plus 2, sp.pen c. Okay, let's print out what sp is now. Run. Index out of bounds for 1. If character I is less than sp.length, oh, okay. We're going out of bounds for this now, because we just get 1, right? Okay, I see. We might have to do another check here then. And s.length is greater than or equal to 3. Reified says, hi Chet, how's it going? Hey Reified, I'm doing good. I'm just reviewing some meta questions today. Well, the rest of the week I'm planning to do that too, because I have like pretty intense interviews this week. Yeah, how are you doing, Reified? Hope you're doing good too. And s.length is greater than or equal to 3. Okay, what do we have here? Hey, we have 7 now. 7, that's the right answer. 2 is just nothing. Okay. And 5 is 5. You're searching for a flat for the rent. Oh, I see. Good luck on that. Are you in Europe? I feel like you told me you were in Europe before, not in the USA. I wonder what the process is like. Oh, you're in Asia. Okay, someone else told me they were in Europe. You're in Kazakhstan. Oh, right, you're in Kazakhstan. Is it like really hard to find rent in Kazakhstan? Don't know what that's like at all. If character is digit. Oh, you know what? And I plus 2 is less than or equal to s dot length is less than s dot length. I feel like then it would solve the case of the second case, just having one character in. Yeah, okay, we have a solution now, just one, and that's one. Okay. I will add this section to my division 1, 2. If it's a digit and my possible operand 2 is within range, yeah, okay. Okay, this looks good. You know what I just realized? My code probably doesn't work. What if I have 3 plus 5 plus 2? That's really bad, isn't it? Yeah, that's really bad, isn't it? Okay, let's do return integer.parseInt sb.toString. Yeah, okay. Everything accepted here. No, I know it's not gonna work if we submit it though. Yeah, it doesn't work if it's like 3 plus 5 plus 2. It's like a recursive case almost. I should have used a stack for this, shouldn't I? Yeah, a stack. Dang, I really screwed myself here, huh? I think I should have used a stack and keep adding numbers to the stack, but if I come across the operand, I pop what's in the stack and I, follow the operation. Yeah, that's what I should have done. Dang it. So it's not gonna work if I submit this here. Zero minus this. What are we expecting? Oh, okay. And we aren't parsing the entire string either. That really sucks. The entire integer. Man, that's really annoying. Oh, it's already 10:30. Dang, I'm really low on time right now. Yeah, it doesn't support multi-digits. Dang. What can we do about that? Sure, let's try to support multi-digits first. I think. Okay. Stoicism says, why don't you get a job? I'm trying to get a job. That's why I'm Leetcoding every day. Wait, I just realized I've done this completely wrong. No. I should have trapped double digits. And I should have made this a stack, not a string builder. Oh no. Do I have time to do this today? you know what? Screw it. Let's try doing this. So this should be a stack. Oh man, stack of integers. This is a... Does Java have a stack class? Java stack. New stack. Dang, we're gonna have to reconstruct everything. Okay. Okay, first pass, get rid of white spaces. Oh man. You know what? I might have to just scrap everything. I'm not even handling like multi-digits. Okay, this is the first time doing this, but for the sake of review, I might just go over what I did last time because I need to move on to system design now. So this was my solution last time. Man, I did it completely wrong, huh? Okay, it looks like I did an array list. Yeah, I made an array list so I can pop stuff, huh? Just like a stack. Apparently s.trim works. Alright. Current character is this. If it's a white space, okay, I still keep track of white spaces, I just continue. If it's a digit, while... So I keep track of the current number, while the next digit, or the next character is a digit, then I keep appending to the string, okay. I add that to the array. Okay, yeah, first pass, I convert everything to... I see. I convert everything to a list of strings, but I consolidate all the integers together, and I get rid of all the white spaces. Pass 2, I handle all the multiplication and divisions. Yeah. So if the current string is equal to divide and multiply, my operand number 1 is the last number on the array list. Yeah, number 2 is... Wait, pass 2 don't remove. Yeah. Yeah, it's the last, my previous number. I can pop that out. Num2 is pass1.get. Okay. I divide and multiply as necessary. Else, pass 2 to add string. Okay, yes, makes sense. Add and subtract. Current string is equal to pass 2 dot get I. Okay, yeah. Plus minus. Equals result. Oh, I see. I don't need an array list anymore because everything is just one integer. Yeah. So my operand 1 is the previous number I stored, just the result. Num2 is the next number. I plus and minus is necessary, and result is equal to integer that parse current string. I see. Yeah, I kind of screwed myself over with my current approach. I didn't even track entire. I had 0 support for multi-digit numbers, just really bad. Okay, you know what? I'm gonna mark this question as to review again. I'm gonna star it. Why did I not star this before? Dragon says the Odin project introduced these website for job search. Ooh. Very nice. Thank you for the website. Huh. Alright. I'll send this to myself. Yeah, sorry guys, I don't usually do this. I usually actually try to solve the question, but I'm running out of time today. But I will do that problem again tomorrow. And all right. Okay, let's move on to system design study now. Damn. Okay, what do we want to do today? Consistent hashing. Last time we did URL shortener, we did notification system. Let's do consistent hashing, sure. It is important to distribute requests/data efficiently and evenly across servers. Consistent hashing is a commonly used technique to achieve this goal, but first let us take an in-depth look at the problem. Wait, didn't we do this before? You just do like you take your hash space and then map all your servers to it evenly, and then when you land in a certain hash space, you go like clockwise to your server, right? Wait, yeah. We did this before. That's your hash space. If you land in here, for example, you go clockwise to server 0. Okay, yeah, we did this. Yeah, we did this. Okay. Okay, no need to look at this again then. Design a key value store. Sure. Key value database is a non-relational database. Each unique identifier is stored as a key with its associated value. The data pairing is known as key value pair. Okay, for performance reasons, a short key works better. What do keys look like? Last logged in as, hash key. The value and key value pair can be strings, lists, objects. Value is usually treated as an opaque object in key value stores, such as Amazon Dynamo, Memcached, Redis. Okay. In this chapter, you are asked to design a key value store that supports the following operations: put key value associated with key, get key. Okay. Isn't it just like a array list of linked lists, maybe? So every time you have a key, you hash it and see which index you want to put it at. Wait, is that what you do? And then you look for, and then in the first layer linked list, you store your key. Second layer linked list, you store your value. I think that's how it works. Okay, let's keep reading. In this chapter, we design a key value store that comprises the following characteristics. The size of a key value pair is small, less than 10 kilobytes. Ability to store big data, high availability, high scalability, automatic scaling, tunable consistency, low latency. Single server key value store in a hash table. Oh, yeah. Well, I guess I was designing a hash table from scratch. Fitting everything in memory may be impossible due to the space constraint, data compression, store only frequently used data in memory and the rest on disk. Okay, yes. We need a distributed key value store, yeah. Oh, if it's distributed, then we can probably shard the key somehow. Yeah. Maybe like all the keys of a specified range go here, this server, another key range goes to this server. Okay. When designing a distributed system, it is important to understand CAP, consistency, availability, partition tolerance theorem. Consistency means all clients see the same data at the same time, no matter which node they connect to. Availability means any client which requests data gets a response, even if some of the nodes are down. Okay. Communication break between two nodes. Partition tolerance means the system continues to operate despite network partitions. CAP theorem states that one of the three properties must be sacrificed to support two of the three properties. I mean, if you move consistency a bit lower, then you can have all three in the middle. Okay, so you can only have two at once. Consistency and partition tolerance. Availability and partition tolerance. Or consistency and availability. Okay. A distributed system must tolerate network partition. Thus the CA, okay, so we have to go with these two. Consistency and availability. Ideal situation, data written to N1 is automatically replicated to N1 and N2. N2 and N3. Okay. So we have three servers just with the same information, and we redirect traffic to either one. Okay. Using load balancer, I guess. Partitions cannot be avoided. Figure 6-3. Yeah, N3 goes down and cannot communicate with N1 and N2. Okay, yes, makes sense. If we choose consistency over availability, we must block all write operations to N1 and N2. Okay, so we're choosing only to write from one server then? And then N2 and N1 are perhaps only read operations? So it's always consistent, I suppose. H3 will always contain the most up-to-date data. Wait. Yeah, and then they copy to N1 and N2, and we read from these. Alright. I think that's what it means, I'm not sure actually. We must block all write operations to N1 and N2. Okay, wait, yeah, so N3 is the master, N1, N2 is a slave. Okay. However, if we choose availability over consistency, the system keeps accepting reads, even though it might return stale data. For writes, N1 and N2 will keep accepting writes. The data will be synced to N3. I see, okay. N1 and N2 keeps accepting reads. Wait, writes. And they sync the data to N3. Okay. Okay. This is kind of confusing. So for consistency over availability, we block all write operations to N1 and N2. So I assume these are all read operations. N3 keeps writing to them. Okay. How long is this section, by the way? Dang, it's pretty long. Oh my goodness. Okay, we're probably only gonna finish part of this today then. The content below is largely based on 3 popular key source systems: Dynamo, Cassandra, Bigtable. Okay, so we split big data into smaller partitions and store them in multiple servers. Okay. Oh, okay. They're reviewing consistent hashing here. We have a hash ring. Servers 1 through 7 are placed here. Key 0 is stored in S1. Yes, okay. Servers could be added and removed automatically depending on load. Data must be replicated synchronously over n servers. Okay. Key 0 is replicated at S1, 2, and 3. Oh, okay, okay. You replicate the next few to my clockwise direction. Replicas are placed in distinct data centers. Okay. It must be synchronized across replicas. Okay, W is write operation must be acknowledged from W replicas for it to be considered successful. R is read operation must wait for responses from at least R replicas. Okay. One acknowledgement. I see. W plus R greater than N. Strong consistency is guaranteed because there must be at least one overlapping node that has the latest data to ensure consistency. Read is 1, W is N for fast read. I see, okay. Fast write is just one act needed. Usually N is 3, and W equals R equals 2. Okay. Versioning means treating each data modification as a new immutable version of data. Okay. Return John. Okay. Server 1 changes the name to San Francisco. Server 2 changes to John, New York. Okay. Vector clock is server, version pair associated with a data item. This sounds important to note down. Vector clock. Server, version pair. It can be used to check if one version proceeds, succeeds, or in conflict with others. Okay. If data item D is written to server SI, the system must perform one of the following tasks. Increment VI if SI exists, otherwise create a new entry SI1. Okay, version 1, I guess. Right handled by server X, right handled by SX, SX2, right handled by server Y or Z. So a different server handles these things? Reconciled and written by SX. Okay, here it explains here. A client writes data item D1 to the system, and the write is handled by server X, which now has a vector clock D1 SX1. Okay, data 1, server X, version 1. Another client reads the data, the latest D1, updates it to D2, and writes it back. D2 descends from D1, so it overrides D1. Alright. Assume that the write is handled by the same server SX. Okay, so it's now D2, server X, version 2. Another client updates to D3 is handled by server SY, which now has a vector clock D3. Oh, okay. So it actually stores it. It stores the version on the other server, SX, 2, SY, 1. Okay, so it stores the other server's info too. Another client reads D2, updates to D4, so D4 is SX2, server Z1. Okay. When another client reads D3 and D4, yes, it is a conflict. Conflict is resolved by the client. Assume the write is now handled by SX, which now has D5. SX3 is Y. Okay. Okay. How do we resolve the conflict though? How do we know which one to use? If the version counters for each participant is greater than or equal to the ones in version X. How much more reading is this? I thought we were learning about hashing. Why are we learning about distributed servers like this? Gossip protocol. Each node maintains a node membership list. Wait. You need 2 independent sources of information to mark a server as down. Okay. Each node maintains a node membership list. Heartbeat counters. Okay. If the heartbeat of a node has not increased for more than predefined periods, the member is considered as offline. Okay. Okay, that makes sense. So to like tell others that it's still alive, the node sends like so-called heartbeats to other nodes, and if more than one node detects that this hasn't sent out a heartbeat in a while, then it's considered dead. Okay. It chooses the first W, healthy servers for writes, and the first R, healthy servers for reads, on the hash ring. Okay. Another server will process requests temporarily. Okay, handling permanent failures. I think I'm going to stop at the halfway point here. Oh, this was a lot of information. Alright, yeah, that is it for today's stream then. We started hashing. For some reason, we're learning about distributed systems now, handling failures and whatnot. We reviewed some problems. We had one that I ran out of time to solve, unfortunately, but I'll solve it tomorrow. Okay. Thanks for coming, everyone. I appreciate it. Thanks, Dragon. Thanks, Stoicism. Thanks, Reified. I appreciate. See you guys tomorrow. Bye. Roshan says best of luck. Thanks, Roshan. I appreciate.